and Tomor, and I'm a bridge engineer. So I did a bridge engineering degree that was in Germany some time ago. And I've been working in academia ever since. I did a PhD and my topic was internal force distribution in masonry arch bridges. So I somehow ended up looking at masonry bridges since I did my degree. And I love my bridges. I love stone bridges. Let me just stop the transcript. Okay. My interest in bridges is looking at how long these structures have been used and how long we can still continue to use them. As you know them well, you know that these are very old structures, and then I'm very keen to pick this up as a really good idea for a real potential for the future. So I'm looking at the performance of heritage bridges or old bridges and try to see how the technology can be adopted for new construction. So I'm going to share the presentation. And you have to. Okay, let's see if you can tell me if you can see it. Can anyone see it?
Yep.
Okay. Good.
Yes, thank you.
Good, brilliant. So I work at Brunel University, just on the outskirts of London near Heathrow. And I'm doing lecturing as well as research. I teach structure engineering and materials, that sort of things. And I'm a course director for structure engineering MSc, which is great. The students are brilliant. They're so keen. One of the modules that I teach is infrastructure management. And within that, I ask students to, I talk through bridge inspection with them. So they look at concrete, steel and masonry bridges, structural behavior, materials, defects, causes of defects, testing, monitoring and maintenance and refurbishment. So this is part of the MSc schedule, which is attended by structural engineers as well as infrastructure management students. So I was shocked how many there are. There were about over 100 students this year. So what is fun in this? Their assignment is to pick 2 bridges, any bridge anywhere in the world that they like, use the inspection sheet to do general inspection on those bridges, write about the defects, causes of defects, monitoring, maintenance proposals, and present everything on a website that they create. And you know what? This is the most popular assignment that they have ever had. They say that they love bridges. So if you need any students anyone who you need to do bridge inspection, I've got lots of students interested. So that's great. I love when people get enthusiastic about what they do. Now, here are a few pictures, and if you can unmute your camera, your microphone, I'll welcome little bits of feedback. When do you think this? Well, first of all, do you know does anyone recognize this bridge by name or location? And yeah. When do you think it was built? Either of those questions.
It's the Glenfarne Viaduct. And it was, I don't know, 1850 maybe.
1850, okay. We can only guess. So that's I think that's a really good guess. Let's see whether, yeah, is that the one?
1901.
1901. It was a concrete structure, I think.
Is it really?
Yes, it is.
Yeah.
I never realized that. That's interesting. Right, so there's the next one. Does anyone know which one this is? Hopefully it's not concrete this time.
It's in the Scottish borders.
And
Garlafoot.
Estimated guess when it was built, roughly, plus minus 50, 100 years.
1870.
1870, let's see. Wow, you're good. And could someone admit, whoever is trying to get in? Now, this, looks beautiful. Does anyone know which one it is? It's or when do you think it was built roughly?
1750.
1750. Good guess. So this is called, I probably know, built in 1605. So that makes it 400 years old. It's a beautiful bridge. The ring is very thin, so I guess the ring thickness actually is much greater than what we can see. Which one is it? Do you recognize this?
Sterling.
Sterling, okay. And any guesses when it was built? Plus minus 100 years or 200 years. Yeah, so this was, well, Sterling was 1500s. So that makes 500 years. Brilliant, beautiful bridge. There's another beautiful one. Anyone who's come across this?
A Brigadoon, is it?
Yeah, that's the one. Well done. Again, an age, roughly?
1720.
Nearly.
Right.
500 years plus. Okay, so those were some amazing Scottish examples. And pop down to Devon this time because Kevin Dentist, do you know Kevin? He's been the chairman for the Bridge Owners Forum and is very involved in national bridges meetings. So he is looking after 3,000 bridges in Devon, and some concrete, some metallic, and some masonry. However, most of this is another nice one, Bideford, 500 plus years. So this is how many bridges he has. So 70% of all his bridges, all the Devon bridges, are masonry, 10% are metal, and 20% are reinforced concrete. Obviously, it's not typical across the country, but he has rather lot of bridges. Now, how much does he spend on maintenance? And that would be very interesting to get information from yourselves. How much do you spend on maintaining masonry, metal and reinforced concrete bridges? Well, as it seems like that he's only spending 3% of his budget on the 70% of masonry bridges, but he's spending 77% of his budget on the 10% of metallic bridges. This is crazy. And then in terms of CO2 emission, looked into that. So masonry is about 12%, metallic is 47%, and reinforced concrete is at 42%. So just a little bit of takeaway from this, that maintaining masonry bridges, as you probably know, it's not expensive, it's actually the cheapest, and the CO2 emission is much lower than anything else. So this is just a brief summary how much, what the cost of maintenance, so what is spent mostly on substandard parapets, waterproofing, post-tensioned inspection, joints and bearings. They all are related to steel and reinforced concrete elements. So masonry doesn't really feature much here at all. So we all know how long these bridges last, and the last two examples you may or may not recognize. Pont du Gard, I'm sure you do, which is 2,000 years old, and the next one is in Rome, St. Angelo, again built by the Romans. So we have clear examples of masonry bridges lasting 500 years or 2,000 years. So clearly long lasting. Now, I haven't really come across any new bridges. There have been some brief replacements, particularly in canal bridges, but very, very few, if any, at least in England, and I'm not familiar with Scotland, which are newly built. Now, I came across a project. Well, they haven't been built since 1920s. So the technology is basically 100 years outdated. And people think that they are too expensive and difficult to build. Now, someone contacted me from Tanzania, actually a Belgian engineer, because they've got an incredible project building 70 new stone bridges. And if you anyone have seen any pictures of this, you recognize that. And Annabelle is the Belgian Development Agency. They've got an agriculture project in Tanzania and within this project, they are helping people to get to markets. Working way out in the countryside, they're helping local communities to build stone bridges using local resources, obviously. So the initial idea was to build bridges, but after looking into the cost, it was impossibly expensive to build concrete bridges. And there are some amazing people in Tanzania among the Belgian engineers or agricultural people. And one of them has been building these bridges for 20 years in Kenya and Tanzania. It's quite incredible. No one has ever heard of that. So they initiated this project and they're now building 70 new stone bridges in Tanzania. They're building those 70 in the northwest region here, and they are now, the project has been very successful. So they are now starting to build stone bridges all around the country. So that means 70 built within 2 years, I think 2 or 3 years project, and now they're rolling it out all across Tanzania. So that will be literally hundreds of stone bridges coming up. So I was very interested to go there in November last year and see how they're actually doing it. Everything is done by hand. There's no electricity on board. And they're obviously using very simple technology. So long tapes for setting out. The local community provides the stones and digs the foundations. The Belgians then pay for stonemasons to build the bridges. And they keep very strict quality control over during construction. So here the foundations have been dug and built. Next step, so this is just a step by step. The Belgians provide the centering. They deliver it on site, and this is the set for one 8-meter span arch bridge. And because it's quite a long span, they can't say they bring it in 2 sections, so one on the left, one on the right. They put it together on site, put it up. And you can see the alternative, how local people would cross the bridge otherwise. They put the sections up, so these are sections they secured, and they start putting planking on. After that, they start building the arch. They are very conscious about making sure that the largest stones are used for the arch ring, and anything smaller above that. They're also very conscious about making sure that there is a 90 degrees angle to make sure that all the stones are in compression. Here the arch ring is nearly completed. The last bit is then put in. Actually, it's quite interesting when you talk about what's the ring thickness. It's not easy to estimate. They're conscious of, once they know, they're given the design for the arch ring, for the arch, with the minimal arch ring thickness. So they try to use stones which are larger than the required ring thickness. So hopefully most of those stones are greater than required. However, what is effective arch ring thickness is really hard to estimate. So when you're trying to analyze it, it's basically you make the best estimate you can. Here the arch has been completed and the backing put up. Here the parapet built. They use very small parapets, but it's just Tanzania. Here's one of those pictures that you very rarely see before the bridge, it's filled up. Here they've got more backing, and then backfilling, and then here's some completed bridges. Beautifully built, and there's a lot of them are 8-meter span. Some are smaller, some are multi-span. So there's incredibly well-built bridges. They keep very strict quality control. And in one case, I haven't got a picture, but the stonemason didn't fill in, didn't put enough mortar in between the stones. So they were very keen for that to be taken apart and built properly. What else? Right. This was the two pictures. So this picture was taken, and this one soon after. How many days or weeks or months or whatever do you think passed between the two pictures? How long do you think an archery ring takes to build? How much?
6 weeks.
6 weeks. Yeah, it's 11 days. So this was, they had to finish the planking and then build all the stone, everything done by hand, 11 days. So basically a week and a half to build an arch ring. It's surprisingly quick. And these are the guys doing it. Could someone let anyone in? So the guy in the middle, he is the stonemason, and the 4 are trainees. So during this bridge, during the construction of this bridge, he's actually training the 4 guys who will then have the opportunity to apply to become lead stonemason for the next bridge. So they also connected with training. So basically 5 guys on site do everything by hand. They have the odd helper, but that's the team. And they build basically a bridge in a month. So this, because it's 2-span, it might take 6 weeks or 2 months, but certainly it doesn't take longer. The only reason it would take longer when they've got the monsoon season, that means that the water level rises by about a couple of meters within a matter of hours, and they have to stop. This is one of their first bridges, and which was built. Really interesting, really well built, amazing. So I mentioned why they actually selected this type of construction, and that was because of cost. Stone bridges cost about 84% less than concrete would. That's in Tanzania, obviously, not in the UK. Associated with this, CO2 emission is 77%-ish lower than concrete. So it's a secondary benefit, but the primary benefit is the cost. Now, that is a developing country. How is that relevant to us in the UK? When I lived in Bristol, I came up with a proposal to build a stone arch bridge in Clifton or on the Downs. So that would connect the 2 parts of the Downs, the park. We got planning permission. That was the first big stone bridge that received planning permission for, I don't know, 100 years. So they were delighted to get it. The project was then stopped because of another permission we needed, which was to do with the status of the Downs rather than the bridge. So they just basically don't want anything built on the Downs. So the design was to build 3 times 14 meter spans. The bridge would have been strong enough for standard highway loading, or it would have been a pedestrian bridge. So during this project that I worked on that just on a voluntary basis for 5 years. So put the plans together, did the consultation, submitted the plans. It was a really good learning exercise to see where are we with bridges, with stone bridge construction. And basically no one has done it. Anyone who has built a stone bridge basically have died because the last bridges were built in 1920s. So no problem, we can relearn it. It's just a matter of finding what technology, how to build them and relearn it. I looked into the costs because one of the immediate thoughts people might have that, oh, it costs too much. Because none have been built basically over the last 100 years, is very hard to estimate. So estimate for a steel bridge for that particular bridge would have been about $1.5 million. if we built out of bricks, a brick arch bridge, brick masonry, it would have cost roughly the same. If we selected stone, cut stone, it would have cost about 30% extra. So the cost, additional cost is mainly the materials and some labor, but labor actually isn't that expensive. You only need really quite a small team. So it would have cost probably about 30% more. However, stone bridges would last 300 to 500 years, I estimate. Brick masonry might last you 200 to 400 years, and steel 100 to 200 years, or so, rough estimate. Now, the government is really keen on embedded carbon. What they're not keen on is actually looking at how long we are building for. So I think it does make a difference that you are building something that's going to last you 300 years or 500 years, instead of something that you are building for 50 years and potentially going to have a whole load of problems after 50 years. If you look at the long-term costs, so per year, the slightly cheaper steel, well, the standard steel would actually much more expensive if you spread the cost over the life expectancy. So this is one of the issues that I'm very keen for government to reconsider how sustainability is evaluated. Embedded carbon, to me, makes very little difference on the long term, very little difference. If anything, it can be counterproductive. We want to make sure that things last to avoid lots of maintenance and lots of replacement. Let's build something which is good quality, requires low maintenance and going to last. And it's much easier to do that, deliver that out of masonry, particularly stone masonry, rather than concrete or steel. Obviously, masonry doesn't fit everywhere, so you might have the opportunity to build small masonry bridges, but if you've got 100-meter span, obviously that wouldn't be applicable. So I'm not suggesting we need to replace concrete and steel with stone, because that wouldn't be true, but I'm suggesting that stone has the opportunity, has the potential to be used wherever it is suitable. Looking at the environmental impact for maintenance, steel and concrete has roughly the same CO2 emission over the maintenance phase. So I'm not talking about embodied, it's carbon, I'm talking about the maintenance during the estimated, let's say, 120 years life expectancy, and masonry is about a quarter. So it's a little summary. Feasibility of how we can use that for the UK. So CO2 emission for masonry, which is the dark blue, is about 20% compared to concrete and steel. So when if the government wants to deliver low emission construction, I think you just can't ignore this. And you can never deliver that sort of figures using concrete or steel. Construction time. Well, you've seen the two pictures. An arch bridge would take them a month to build. I reckon the construction of masonry, stone masonry, would be roughly the same as concrete or steel. You can do it quicker if you like, but I don't think it would take longer. And you see those pictures. And the third aspect, costs. I mentioned about 30% extra, perhaps, but what if you are out in the countryside, you haven't got cast stone, but you've got rubble. Rubble is just as good. So if you are using, you could use waste material from quarries to build stone bridges, like similar to the Tanzanian designs. The cost of stone will be minimal. You can almost get the stones for free, because a lot of the quarries, but some of the quarries actually who produce cut stone can't use a lot of the waste. So the waste is about 40%. cut stone production. So 40% of all stone is put back into the ground. Now you could probably get it quite cheaply. And for random rubble arch bridges, it doesn't matter what size they are, as long as you've got some large ones for which you use for the arch ring, and you put the smaller pieces on top. Life expectancy I mentioned, and it lasts probably twice as long. Now, how does it fit in, and what is the business case? Now, if you like masonry bridges, it might be challenging to persuade someone who doesn't know anything about stone bridges why this might be feasible, or that this might help, but also in terms of environmental impact. So that's an upcoming aspect, obviously, for any construction. So environmental impact, and I think I mentioned, it needs to be realistic. 120 design life doesn't fit all. It might be realistic for concrete or steel, but why 120 for masonry? When the Victorians built to last forever. So I think the life expectancy must be included into any new design. But it has to be a realistic one, not the design life. And we also need to include the maintenance and associated traffic delays into any estimate for environmental impact. So instead, my suggestion is instead of using the 120 years design life for estimating the environmental impact, why don't we just estimate the life expectancy, whether it is 50 years, 120 or 300 years, and use that to evaluate the environmental impact. This must be included somewhere in the design. It's not policy at the moment. There's actually no central policy how to do it. There are suggestions how to do it, but most of them focus on embedded carbon. Maintenance tends to have actually the same carbon impact as the embedded carbon. So reducing the embedded carbon endlessly doesn't really make much sense. And you've seen this picture previously. So it's okay. In terms of business case, you might argue that it is a long-lasting construction, it is low emission, but how can you do it? Now, the Tanzanians are really, really good at this. They put together a design guide, which is called Stone Art Bridges, a strong and cost-effective technology for rural roads. This was put together by Enobel, the Belgian Development Agency, and the Tanzanian Rural Roads Agency. Or this may have been a previous collection of previous document. It's only about a 50 or so page, very easy to read document, and it's brilliant. It's so clever. You can give it to someone in a local village, and it tells them about the principle of stone bridges, how to build them, with lots of pictures, with correct and wrong and incorrect, what to do, what not to do, how to build it step by step, how to build your stone bridge. And then also it gives them tables. And the tables include everything, like how many wheelbarrows, how many, I don't know, gloves do you need, how much timber do you need. The centering is given to the local for these constructions. So they build the centering and then they take it down, take it back to the warehouse. Now, if you are interested in Scotland to start building these bridges to reduce costs, you might start to think, actually, if we have a few sets of timber centerings, we might be able to just borrow that for a couple of months, take it back, someone else can use it. So that would radically reduce your construction costs. And the best thing that they do in this manual is having those two tables. One is a table for semicircular bridges, and one is a table for segmental bridges. Let's have a quick look. So here you will have the span. Ring thickness is V. And then you've got the abutment lengths, the backing heights. Excuse me. So they give you all the information, all the dimensions you need, and that's what they use. So the Belgians, if they want to build an 8-meter span bridge, they can make it either semicircular or segmental, and here are all the dimensions. Incredibly simple, and that's what you need to make it easy for people to do it. We are going to, I'm looking to organize a group, working group, and if anyone interested, please let me know, to update this guideline to become an international one. So obviously materials and local requirements would be slightly different, but I think these tables and the whole setup of this design guideline is incredibly helpful. So let's look more strategically to the future. Sustainability is well known, whole life costs, that's obvious, long life expectancy, obvious, and resilience. Yeah, traffic has gone up enormously since the Victorian times. Those bridges are still serving today's traffic because they were over-designed. I think it's a good idea to over-design structures, but reducing everything, minimizing everything, which is the current trend in design and for architects, minimize everything. I think it can be counterproductive. For masonry bridges, the arching, like this, is the load-bearing element. And the thicker it is, the stronger the whole bridge will become, more or less. So it makes sense to make it slightly thicker so that you add an extra, I don't know, so many tons and an extra 100 or 200 years. What is missing, or just partially done, is the digital aspect of stone bridge construction. So when these bridges were last built in the 1920s, the technology has been pretty medieval and they haven't changed since. However, there's a whole range of potential technology which could be adopted or is already been partially adopted into the industry. So we can like look at the Tanzanian bridges, build small scale stone bridges. That's not a problem. Technology is not difficult. My aim is to adopt the technology to allow people to build at a larger scale, not bigger bridges necessarily, but more, and make it easy for people to build. That means that we need to make the technology easy and the design easy. I think what would help towards creating an opportunity for large-scale, modern large-scale construction is, for example, including design software and guidelines. So people need to gain confidence and get guidelines how to do this. So simple design software is the best way. There isn't anything really. There's Archie and Ring are the two dedicated masonry arch beam assessment programs, which I'm sure you're familiar with. So you can use those to design bridges. We could think about developing dedicated design softwares for stone bridge construction, and this needs a little bit of development. However, we are not very far from that. It's really quite doable. Now, there's a lot of development in digitization and optimizing. I think there is a good opportunity here to also adopt it into, say, quarrying, stone cutting, transportation, and construction. Optimization is being adopted in very many sectors, so we can just sort of adopt it in here as well. Automated construction. It's really exciting. I'm just talking to the robotics people here at Brunel University, and we are starting a new project to use, actually, let me just show it, to use robotic arms. This is just a model, to use robotics to build stone bridges automatically. So automated stone bridge construction. So this is one of the little robots that we have.
And this concept is being renovated.
take the sound down. So you can have a robotic arm and you can get it to pick up stone, place it. If you put sensors in, you can make it do really quite sensitive and gentle tasks. So this is just one of those things that could easily be adopted, and we are developing a pilot study for automated stone construction for art bridges. Similarly, games technology might be an opportunity to incorporate. I mean, if you can, using joystick, you can, instead of, so you can just build remote control, build remote control. So very little reason sometimes for people to be right there. I'm sure we can adapt technology to help. And I think people that expertise, knowledge and ability of people could be then spent somewhere which that technology can't deliver. So I want to utilize human resources to make people do whatever they can really do and sort of up the technology rather than get people doing things that machines could do potentially. Now, sensors could be adopted. I don't think sensors are very much adopted into concrete or steel bridges, even today. However, my plans are to start including sensors into new stone bridges. Not that really that they critically needed, but it would be a useful feedback mechanism to just to keep an eye on things. So the government again is looking for digital technology, digital infrastructure. If we start reintroducing stone bridges with sensors already built in, I think that would be a much stronger business case for that as well. We might use digital twins, asset management, development could be incorporated. BIM, it's not very easy to adopt for stone construction, but it might just need a little bit of research and development to be able to do that. And where are we at the moment with those technology? In terms of 0 to 100, I think in terms of sustainability, life cycle cost, life expectancy and resilience, I think we are very high up. Concrete and steel would probably be at the lower down somewhere here. And what about digital technology? How far is digital technology included in stone bridges? I think there is already a lot being done. For example, stone cutting, CNC machines, they are obviously very much automated. So there's a lot of digital technology included already. But I think there's a lot more potential to bring it up to speed with anything else and go beyond any other building method, building material. So if anyone has any opportunity to pilot the scheme in Scotland, please let me know. I would be very interested to hear from you. We are looking to build the first stone bridge in England in Devon next year with Kevin Dentis. So he's just looking for a suitable location, and it will probably be about an 8-meter span bridge. So if you've got any opportunity, either rebuilding or building a new one, and you'd like some help, you'd like to work with people who are also interested and initiating new stone bridge construction projects, let me know, because we are all here to actually build up the expertise and help each other. Thank you very much. Do we still have anyone left?
There's a lot of us left.